we're looking at the remainder and factor theorems, and these are used so that you can find a remainder of an equation when it's divided by another equation, or whether a linear equation is a factor of a larger equation without going through the whole process of dividing using division of polynomials. So if you wanted to find out if f of x was if a factor of f of x was x minus a, then you would sub in a as your x terms, and if it equals 0, then that means that x minus a is a factor. If it doesn't equal 0 and it equals another number, the number that it ends up with is the remainder. So they are quite similar. I'll give an example of both of them. So I'll give an example of a remainder theorem first. Right, so the question is, find the remainder when 2x cubed minus 3x squared plus x plus 5 is divided by 2x minus 1. So first of all, I'm going to say let f of x equal 2x cubed minus 3x squared plus x plus 5, so that I can use the function notation. Right, and now I want to find out the x value for this linear equation. So all I do is make the linear equation equal 0, so 2x minus 1 equals 0. I add 1 to both sides to get rid of 1, so 2x equals 1. I then divide both sides by 2 to get rid of the 2 on this side, and divides 1 by 2, which is a half, and now I have x on its own, so the x value is a half. So now I can sub it into f of x. So when f of x is f of a half equals 2 times a half to the power of 3 minus 3 times a half squared plus a half plus 5. Now I'm going to simplify this. So 2 times an eighth minus 3 times a quarter plus a half plus I'm going to put this over 2 so it can make it easier for myself. So plus 10 over 2. Right, now I times this, so this becomes a quarter minus 3/4 plus 2 over 4, which is a half, plus 20 over 4, which is 10 over 2, which is 5. So I can simplify this. So quarter plus 2/4 plus 20 over 4 is 23 over 4. Take away 3 is just 20 over 4. So the answer is 20 over 4, which is 5. So the remainder for this, so when 2x cubed minus 3x squared plus x plus 5 is divided by 2x minus 1, the remainder is 5, and I didn't have to go through the whole division of polynomials to get that. The question is, prove that x plus 1 is a factor of x cubed plus 2x squared minus 5x minus 6, and hence factorise the equation fully. So what I'm going to do is let f of x equal x cubed plus 2x squared minus 5x minus 6, so that I can use the function notation. Then I'm going to make my linear equation equals 0, so I can find my x value. So my x value is minus 1 because I took away 1 from both sides. Then I sub in my x value to f of x, so f of minus 1 equals minus 1 cubed plus 2 times minus 1 squared minus 5 times minus 1 minus 6, so this becomes minus 1 plus 2 plus 5 minus 6, which equals 0 because 2 plus 5 is 7, and minus 1 minus 6 is minus 7, so they cancel out to make 0. Right, therefore I've just proven that x plus 1 is a factor of this equation. So now if I use polynomial division, I can find out the quadratic equation that this has to times by to give this. So x plus 1 is my divisor, x cubed plus 2x squared minus 5x minus 6. And now we go through the whole process of division by polynomials, and the factor theorem is good if you want to factorize an equation fully, because you can test different values of x so that you don't waste loads of time doing lots of division of polynomials. You just use the factor theorem a few times to find the correct value for which the right factor. So x times by x squared gives us x cubed. So x times x squared is x cubed. 1 times by x squared is x squared. Take them away from each other. X cubed minus x cubed equals 0. 2x squared minus x squared gives us x squared. Bring down this value of x, minus 5x. If you times x by x, it gives us x squared, which is what we want, so plus x. So x times by x equals x squared. 1 times by x gives us plus x. And you take them away from each other, so that gives us 0 here. And minus 5x minus x gives us minus 6x. Bring down minus 6 down up there. Now we have to times x by minus 6 to get minus 6x, so we put that up here, minus 6. So x times by minus 6 is minus 6x. 1 times by minus 6 is minus 6, and of course they cancel out to give us 0, as we proved that x plus 1 is a factor by the factor theorem. So we now have our quotient, and we have the quadratic equation that the linear equation has to times by to give us this cubic equation. So I can put x plus 1 is always equal to f of x. So we look there, f of x is always equal to x plus 1 times by x squared plus x minus 6. And if we want to factorise this fully, we can factorise the quadratic equation. So you should know how to factorise a quadratic equation. You have to find two numbers that times to give the end number and add to give the middle number. So 3 and 2 times to make, well, minus 3, and plus 2 times to make minus 6, but so does minus 2 and plus 3. So f of x is going to equal x plus 1. Then we factorise this, so it's going to be x minus 2, because we want a positive value for the middle x, we want a positive 1. So x plus 3, because 3 minus 2 is 1, minus 2 times by 3 is minus 6. And here's the cubic equation fully factorised. So x cubed plus 2x squared minus 5x minus 6 will always equal x plus 1 times by x minus 2 times by x plus 3. And that is more on division of polynomials and using the factor theorems and the factor theorem and the remainder theorem.